Thank you for joining this lesson. Work power, energy and machines. We are told using the pulley system shown, a mass of 10 kilograms is raised 2 meters by an effort of 80 Newton. That is why I've already converted this mass into a weight, because a load is a weight, to get 100 Newtons. Then we are told to first of all answer part 1, which is asking how much potential energy does the load gain. Potential energy is usually the energy gained by a body through or by rising through a given height, and it is usually given by mgh, whereby this is the force times the height through which it has moved. Therefore, the load itself is 10, g is 10, and it is being raised through a distance of 2 meters. So we're going to get 200 joules of energy. Part 2, how far does the effort end move in order to raise the load by 2 meters? So we are given the load distance of the load as 2 meters. Then distance of the effort is the something we want to calculate here. We should know that distance of the load is usually related with distance of the effort by a ratio called velocity ratio, whereby we say velocity ratio is distance of effort divided by distance of load. And here we're going to say, from the machine given here, the velocity ratio is usually the number of ropes supporting the load, and these are going to be 1, 2. So VR, velocity ratio, is 2, equals to distance of effort, which is not known, divided by distance through which the load is raised, 2 meters. So distance of the effort is going to be 2 times 2, which is 4 meters. Then we continue with the question. We also told that was Roman 2. Let me go to the next page, the same question. Remember to subscribe to this channel actually, and to share the link with your friends. So the next page is talking of how much work does the effort is done by the effort. So work done by the effort is also called the work input. Work input in this machine is going to be effort times the effort distance, and the effort is 80 newtons, the effort applied, times 4. So we're going to get 320 joules of energy. So with the work done by the effort, and we also have the work which was done on the load, just to recap, it was 200 joules from the previous page. Then we can proceed to get the efficiency of this pulley system. The definition of efficiency is work output out of work input expressed as a percentage, so times 100. So the work output is the work on the load, which is 200. Work input is the work done by the effort, 320. Then we express this as a percentage. So this is going to be, when we take 200, we multiply by 100, then we divide by 320. I'm getting 62.5%. 62.5%. Then again we are told, if all the wasted energy is used to lift the bottom pulley, how much does the pulley weigh? How much does the pulley weigh? So the wasted energy, we can calculate the wasted energy. So wasted energy or wasted work is happening on the bottom pulley. So the wasted work is going to be 320 minus 200. because this is the work input, but the output is 200. Therefore, we're going to get 120 joules of energy as the work wasted. Then now we are told to state how much the pulley weighs. Remember, work is force times distance. So this work, which is 120, is going to be to the force of the pulley, which is not known, but we are told that it is raised through 2 meters. Therefore, because it is raised through 2 meters, then we can divide through by 2 and realize that the force, which is going to be 6 newtons, is the weight of the bottom pulley. Is the weight of the bottom pulley.